Good afternoon, learners. My name is AT Mokgehle, and today we will be doing mathematics paper 1. It's actually a revision of mathematics paper 1, and we'll be focusing on few questions from paper 1. So let's just begin. 1.1, they are saying if a given f of x is equals to x squared minus 3, open the bracket, close the brackets, open the bracket, 3x minus 1, close the bracket, open the bracket, x plus 2. So 1.1.1, 1.1.1, they are saying if x is an integer, so we will have f at x is equals to x squared minus 3, open the bracket, 3x minus 1, x plus 2. So they said if x is equals to 0, that means we equate everything to 0. We will have x squared minus 3 equals to 0. 3x minus 1 equals to 0. And x plus 2 equals to 0. Now let's solve for x. We will have x squared equals to positive 3. We remove the exponent by the square root. We will have x is equals to plus minus square root of 3. 3x on this side is equals to 1. We divide by 3, we divide by 3. X is equals to 1 over 3. Then x plus 2 equals to 0. X is equals to negative 2. So the question was saying if x is an integer. So if they're saying x is an integer, that means this answer here and this answer here, they are not correct, because an integer is a number that is not a fraction or a decimal. Therefore, let me just use the black one. Therefore, x is equal to negative 2. 1.1.1. Then 1.1.2, they're saying x is a rational number. So if x is a rational number, we will have x as our, this will be our x, and this will be our x. We will have x is equals to 1 over 3, and x is equals to negative 2. So 1.1.3, if x is a real number on all of them, we'll have x is equals to plus minus square root of 3, and let's say or x is equals to negative 2, or x is equals to 1 over 3. Now let's move to the second question. Let's move to 2.1.2. So 1.2, they are saying solve for x. 1.2, solve for x. We are given minus 15x squared minus 9x plus 4 equals to 0. So if you check this equation here, this equation here, it will be very difficult for us to find factors. So we are going to use the quadratic formula, of which says x is equals to minus b plus minus the square root of b squared minus 4ac divided by 2a. So a is equals to 15, negative 15. B is equals to negative 9, and C is equals to 4. So now we just plug in everything. X is equals to minus B is minus 9, minus 9, plus minus 9 squared minus 4, open the bracket, minus 15 into 4, all of them divided by 2 into negative 15. Then when you hit that on the calculator, you will find x is equals to 0,90, or x is equals to 0,30. So let's move to, this was 1.2.1 actually, 1.2.1. So let's move to 1.2.2. We have 3x minus 2 squared greater or equals to 3x. So first thing we do here, we open the brackets, we have 3x minus 2, 3x minus 2 greater or equals to 3x. So now we multiply over, we'll have 9x squared minus 6x minus 6x plus 4 greater or equals to 3x. So now let's group like terms. We'll have 9x squared minus 6 is minus 15. Minus 15, we take the 3x to the other side, we'll have minus 6 is minus 12. Minus 12, we take the 3x to the other side, is minus 15. Minus 15x plus 4 greater or equals to 0. So now we find the factors. We simply open the brackets. We have x. So now minus, here we'll have 3, here we'll have 3, minus we'll have 4. The bigger factor, take the first sign, minus 1. So greater or equals to 0, we will have 3x minus 4 greater or equals to 0. Now let me do this one here. Let me take this one here. I have 3x minus 4 greater or equals to 0. 3x greater or equals to 0 equals to 4, because we are taking the 4 to the other side. We divide by 3. X is equals to 4 over 3. It's supposed to be x is equals to greater or equals to 4 over 3, or 3x minus 1 greater or equals to 0. X is greater or equals to 1 over 3. So let's move to the next question. Just remove that and explain. Okay, student, we were on 1.3. We were on 1.2.3. We are given 5 to the power of x equals to 5 into 4 plus 5, 2 minus x. So from here we start by simplifying. We will have 5 to the power of x is equals to 20 plus 5 times 5 to the power of 2 minus x. So if you check this thing here, it can be written as 5 to the power of x is equals to 20. 5 times multiplying powers of the same base, we add the exponent. So we'll have 5 times 5 to the power of 2 times 5 to the power of negative x. Then from now we simplify. We will have 5 to the power of x is equals to 20 plus 1, 2, 5. Then to the power of negative x, we will have all over 5 to the power of x. Then from here we can say to make things easy for us, we can say let 5 to the power of x be equals to k. So that means where we see 5 to the power of x is equals to k, we will have k is equals to 20 plus 1, 2, 5 all over k. So from here we can solve for k. We can make k subject of the formula by multiplying both sides by k. I'll write this one well over here. Multiplying both sides by k. Therefore we'll have k squared equals to 20k. K will cancel k plus 1, 2, 5. Then let's just write the mixed space here on the top. Then from here we can say k squared equals to 20 k plus 1, 2, 5. We will have k squared minus 20k minus 1, 2, 5. We open the brackets, have k squared k. So we'll have negative, the factors it will be 25 and 5. So the bigger factor takes the first sign. We'll have 25 plus 5. K is equals to 25, or k is equals to negative 5. So now we can come here. We said let 5 to the power of x be equals to k. So 5 the power of x is equals to k, and k is 25. We have 25. 5 to the power of x, we simply write 25 in terms of exponents. We will have 5 to the power of 2. Therefore x is equals to 2. Then on the other side we will have 5 to the power of x equals to k, and k 5 to the power of x equals to negative 5. But if we try to solve for x here, it will be very impossible. Therefore 5 to the power of x can never be equals to negative 5. Therefore k can never be equals to negative 5. Okay, let's move to the next question. Let's move to the next question. 1.3. 1.3, we have log x 16 equals to 4, and y plus x plus 7 equals to x plus 1. So this one will be our equation 1. This one will be our equation 2. So remember, log of 16 base x is equals to 4 can be written as the loss of logs. They say just we will have log, have x to the power of 4 equals to 16. Remember, log, let me just write it here in red, log AB equals to C can be written as log of A to the power C equals to B. So here we will have x to the power of 4 equals to 16 can be written as 2 to the power of 4. Therefore, x is equals to 2. Now you substitute x into equation number 2. You will have equation 2 says y plus x plus 7 equals to x plus 1. Therefore, y plus 2 plus 7 equals to 2 plus 1. Y is equals to root of 9, of which is equals to 3. Therefore, you will have y is equals to root of 9 is 3. 3 minus 3, y is equals to 0. Now let's go to 1.4. Let me just remove this one here. 1.4, they're saying calculate two numerical values for p so that x to the power 3 plus p open 2x plus 7 plus it is a perfect square. So we have x to the power of 2 plus p into 2x plus 7 plus 8. So now first thing that we do, let's multiply by p. You will have x squared plus 2px plus 7p plus 8. Then from here you can now complete the square. You will have x squared plus 2px plus p squared minus p squared plus 7p plus 8. Therefore, you will have x plus p, all of them squared, minus p squared plus 7p plus 8. Equals to. Then from here, you will have negative p squared plus 7p plus 8. Let me write this p very well. Then let's multiply all over by negative. You will have p squared minus 7p minus 8. So now let's find the factors. We open the bracket. You will have p. It will be negative 8 plus 1. Okay, let me check. Negative 8 plus 1 is 7. Yes. So the values for p will have p minus 8 equals to 1, or p equals to 0, or p plus 1 equals to 0. Therefore, p is equal to 8, or p is equals to negative 1. So now let's move to question 2. We are given the following sequence of numbers forms a quadratic number pattern: negative 3, negative 2, negative 3, negative 6, negative 11. Then 2.1, they are saying the first difference of the sequence is also also forms a sequence. Determine the nth term of the first difference. The nth term of the first difference. So here they are saying this sequence we are given 2.1, we are given negative 3, comma negative 2, comma negative 3, comma negative 6, comma negative 11. So for us here, we'll simply find the sequence that they're talking about, of which is the first difference. So negative 3 minus negative 2, the formula, remember, says T2 minus T1 equals to D. Remember this formula. Negative 2 minus 3. Here we'll have 1. Then we will have negative 1, negative 3, negative 5. Then they are saying this is another sequence. So we must find the nth term of this sequence. So we must now first find the common difference. So still we are using T2 minus T1. We have minus 1, negative 2, negative 2, negative 2, negative 2. So they are saying find the nth term, and the formula for the nth term of the first difference sequence is Tn equals to A plus n minus 1 D, where our A is 1 plus n minus 1, n is n minus 1 D is negative 2. This is the D, this is the A, this is the D. Therefore, we will have our formula as 1 plus n to minus 2n plus 2. Therefore, we will have Tn as minus 2n plus 3. Then on the next question, they are saying 2.2. Calculate the 35th term and the 36th term of the quadratic sequence using this formula. So we will have Tn equals to negative 2n plus 3. Therefore, we'll have negative 2 into 35 plus 3, of which will give us negative 2 into 35 plus 3. Negative 2 into 35 plus 3, minus 67, minus 67. So let's move to the next question. This is the T35. The next question says determine the expressions of the nth term of the quadratic sequence. So already we have okay, let's just look at them. We have 3, negative 2, negative 3, negative 6, negative 11. Let's write it here. We have negative 3, comma negative 2, comma negative 3, comma negative 6, comma negative 11. And then we found our first difference to be negative, to be 1, negative 1, negative 3, negative 5. Then the common difference to be negative 2, negative 2, negative 2. Now the formula says Tn. The formula says Tn. The formula says Tn is equals to A n squared plus Bn minus plus C. So from here, we can now find the value for A. We must find the value for A. Tn is equals to A n squared plus Bn plus C. So for us to find the value for A, the formula to finding A is 2A. 2A is equals to second difference. 2A is equals to our second difference is negative 2. That means we divide by 2. We divide by 2. A is equals to negative 1. Then the formula for finding B says 3A plus B equals to first difference. So 3 into negative 1 plus b equals to 1. Therefore b is equals to 3 times negative 1 is negative 3 plus 1 is 4. Okay, then let me write c over here. The formula to find the value of c says a plus b plus c equals to t1. So the value for a is negative 1, the value for b is plus 4, plus c equals to t1 is negative 3. So now negative 1 plus 4 equals to 3. Therefore we'll have c equals to negative 3, negative 3. C equals to negative 6. Then we can now write it here. Tn is equals to an squared plus bn plus c. Our a is negative, so we'll have minus n squared plus 4n minus 6. Then they're now saying explain why the sequence will never contain a positive term. Okay, we already have our sequence there. Just wrap these ones over here. So remember, is a quadratic equation, so it must have a turning point. So let's find the turning point. We'll have x is equals to minus b all over 2a, of which is equals to minus b is minus 4 all over minus 2. Our a is 1. Then x is equals to 2. So for us to find the value of y for the turning point, let me just write turning point. Then we will have Tn equals to a equals to n equals to minus n squared plus 4n minus 6. We just plug the value for x. Therefore we have n is equals to x for this time. Negative 2 squared plus 4 into 2 times 2 minus 6. Therefore we'll have negative 2 squared plus 4 into 2 minus 6, of which is giving us negative 2. Then turning point T P is equal to 2 comma negative 2. So if the turning point for x is, this is for x, this is for y, is 2 and positive 2 and negative 2, that means our graph will be something like this. Let me just say, okay, that means our graph will never have, therefore our sequence will never have a positive term. Okay, then let's move to the next question. Question 4.1. The graph of the graph of the function f of x is equals to a over x plus p plus q, and the graph of h at x is equals to mx plus c as sketched below. write down the values of P and Q. So now, the value for P remember is the vertical asymptote. We are given the graph. We have 4.1. 4.1. We are given the graph. They want the value for P and Q. So the values for P is the vertical asymptote, and looking at the graph, the vertical asymptote there is -2, but then when you take that -2 into the equation, it will now become positive. Therefore, we will have P is equals to 2. Then Q is the horizontal asymptote, of which it will remain -1, not affected by the general term, the equation. This one is the asymptote. Then 4.2, they are saying calculate the value of A. Now we have the value of P, the value of Q. They say they want the value of A. F of x is equals to A all over x plus P Q plus Q. Therefore, let's just take any point on the graph. We'll take this one. Therefore, we will have y is -5/2 equals to A all over -4 plus 2 minus, supposed to be minus here, minus 1. Then now we will have, let's take the like terms together. We'll have 5/2, -5/2 plus 1. We'll have -3/2, -3/2 equals to A all over -4 plus 2 will be -2. Then now we cross multiply. We will have A equals to 6. We divide by 2. A is equals to 3. Then they are saying write down the range of y. Now remember, when you talk about range, 4.3, they're saying when you talk about range, we talk about the y, the values of y. So if you can check there, our horizontal asymptote is y is equals to -1. That means y is the element of real numbers, but y must never be equals to -1. That is our range for this graph of f of x. Let's move to the next question. They are saying determine the equation of m less than 0 in the form y. Therefore, they're saying m 4.4 will have m equals to -1. Then they are saying write the equation in terms of y. We will have y minus m equals to m into x minus 2 minus 2. So now we just substitute. We will have y minus 1 is equals to -1 into x minus 2. Y minus 1 will give us, remember it's multiplication, y plus 1 is equals to minus x minus 2. Y is equals to minus x minus 2, it will be -1 minus 2, it will be -3. So this will be our equation. Then we are getting to 4.5. 4.5, they're saying write down the equation of the asymptote of f at x, x plus 4 plus over 2. So now they're saying write down the equation of the asymptotes of f at x, still the same graph. So what's gonna happen here is that they are saying our graph has shifted 4 1/2 to the left. So shifted 4 1/2 to the left. That means only our x asymptote will change. Therefore, we'll have x, it will be -6 1/2. Then y is not affected since this thing is only on the vertical asymptote. The graph is shifting to the left. So we'll have y is equals to -1s. It didn't change here. Here it is. So let's get to the next question. Question 6. They are saying given f at x is equal to 3 to the power of x, determine the f to the power -1 in the form y. In the form x to the power -1 is x is equals to. Then they are saying they want actually the inverse. They want the inverse of 6.1. They want the inverse of 3. X is equals to f of x. So the f of x, the f inverse of x, it will be, remember now what we're given here, they want us to give them the inverse of this graph. Let me just check my notes there. So when you are making the inverse of 3 to the power of x, you will have log 3x. So there is our inverse. This is our original function. Then this one is our inverse. Original function, inverse. So question 2: sketch the graph of f and the inverse, clearly showing the intercept and the x-axis and the y-axis. So firstly, we must find. Let's put f of x here. F of x. Then the f inverse of x. So now we start finding the intercept. Intercept of 3 to the power of 0, f of x is equal to 3 is equal to 0, then we will have 1. Then now our intercept in this case, it will be 0, 1. Then this side, let's find the intercept. You will have f at x of log 3x. Then from here, you will just say log 3x is equals to 0. Therefore, you will get your coordinates as 1, 0. Then now, for the f of x, for the f of x, we must have the asymptote, and the y at x, we must also have the asymptote. So for f of x, our asymptote, it will be y is equals to 0, and this side it will be x is equals to 0. So now let's plot the graph. Let me plot it in the next page actually. Plot it over here. My pencil is not responding correctly. Let me put another thing and see if it's gonna work. We'll have okay. Now I think it's working nicely. So now let's just plug in our intercept. We have 0, 1. Okay. We have 0, 1. We'll have a point here. 1, 2. -1, -2. 1, 2. -1, -2. So from now, we'll now plug in our coordinates. We have 0 and 1. Then another coordinate is 1 and 0. So it must be somewhere here. So we said y is equals to 0 in terms of the asymptote. Y is equals to 0 and x is equals to 0. Then now let's draw our graph. We will have something of this nature on this side. Let me use a different color. Something of this nature. This will be f of x is equals to 3x. Now remember, the graph on the other side, like an inverse, when you are drawing the graph of an inverse, like when you try to put an inverse on top of the original function, they must look the same. So that means it must be the reflection of the other graph. We will have something like this. Then it will be f inverse of x. Then now after this, we can now draw our let's check what they required now. After this, the next question they were saying, show the axis and the asymptote. So our asymptote here, we will have, our asymptote will be here, where the graph reflect each other. Our asymptote will actually be here. Let's remove this. Okay, then they say write down the equation of the line of the symmetry between the two graphs. The line of symmetry between the two graphs, looking at the graph. Okay, this is our line of symmetry. We will have x, and let me write it over here, 6.3. 6.3, y is equals to x. That will be our equation for the line of symmetry. So now let's move to the next question. For which values of f at x will f of x be, for which values of f of x times the inverse of x be less than or equals to 0? So let's come here. Let me just make a space over here then. Let me just make a space over here. So what they're saying here is that we will have 3x, 6.4, we'll have 3x times log, let me remove this, times log 3 x b less than or equals to 0. So from here, we will now say 0 x to -1, because when x is 1, 3 the power of x, when x is 0, I meant to say when x is 0, okay, log of 3x log of 3x. So when x is equals to 0, when x is equals to 0, we will have this limit. So now let's move to the Next, these are the values, I mean to say. Let's move to the next question. 6 point, write down the range of 3 to the power of x minus 4. So range, remember, it must be in terms of y. So we will say our range for 6.5. 6.5, we are given h at x 3 the power minus x is equals to 3 to the power minus x minus 4. So our range here, y, must be greater than, is it negative or positive 4? In this case, it will be negative 4. That's the range of y. Y is the element of real numbers, and y must be greater or must be greater than negative 4. Then 6.6. Write down the equation of g of the graph g in the image of the graph f after f has been translated to 2 units to the right. So they are saying this graph here has translated 2 units to the right. So that means we'll have f of x. Is it f of x or g at x? G at x is equals to minus f into x minus 2. Remember, they're saying the graph has been translated 2 units to the right and reflect about the x-axis. So we will have, let me zoom in, is equals to negative 3 to the power negative x. Then they're saying it must be x minus 2. Do we have x minus 2? Which equation are they talking about actually here? Okay, they're talking about the first equation of f. So I made a mistake over here. They're talking about f. It's not this one. It's not supposed to be negative here. It's supposed to be 3x. 3x. Since it's shifting negative 2, we'll have minus 2. This will be our new equation because the graph has now been translated 2 units to the right. So when we go to the right, we subtract. When we go to the left, we add. Okay. Here I've organized some questions from paper 1 so that you can practice them during your spare time. I have question 1, question 2, algebra, number sequence, and also functions over here. So just make sure that you practice them, then we will meet when we meet. Thank you so much for your time and your patience. Thank you. Take care of yourself and good luck with your